with the engram data structure. um, so now all the screen and everything is perfect and we can move on. Okay. So all of you be focused and be attentive towards the class. um, I have taken a leave for 15 days due to some emergency work, and right now again we are coming to track, right? So today we are going to see engram data structure. So what is called as engram data structure? So in information retrieval system also we require to make use of the data structures. So we have seen before to that stemming is one of the approach which can be get used so as to perform your okay. So like streaming, what does the streaming do? In streaming there is a concept of removing the extra alphabets, okay, like a particular word is there and after that the extra alphabets are there, like 8 or ing. So those we can able to remove by making applying certain rules, certain conditions on the stems, and we require to obtain exactly the correct word. So that we have seen. So now in engram, instead of like your stemming, so it is going to focus not onto the semantics. There we are focusing onto the semantics. Semantic means the exact meaning or correctness of the word, but here we are going to focus onto the substring concept. What is the concept that we are going to use is nothing but the substring concept. Okay. So engrams are nothing but these are nothing but the equal size of words or equal size of the characters. Grams are called as the equal size of words or equal grams of characters by which we are breaking our data, or by which we are breaking your sentences or query. So into equal size we are going to break it. So what do we do call it as? So engram is nothing but a special type of a data structure, and in that we are having a fixed size of characters, okay, or a fixed length that we do call for breaking our data into segments. So we are dividing or segmenting our data or characters into equal size or fixed size of width, okay. So that is called as engram approach, which does not focus onto the semantics, but it do focus onto the concept of breaking the words into fixed sizes or fixed length. Okay. So how does the searching is going to be get performed in the engram sort of data structure? So engram data structure, as we discussed, it is going to based onto the concept of the substring, or we do call it as a breaking your data into separate grams. So these grams are called as an unigram, bigram, trigrams or pentagon. So how, what is the size you are taking? Are you breaking it to a single word or double words or three words or four words? Likewise, you do call it as a unigram, bigram, trigram. Like this, it is go on exceeding what is the size of your sentence, depends on to the size of your sentence or paragraph. If you are talking about the complete paragraph, or if it is a unique word, then dividing the word into several characters, that is also possible over here. Now why do we use this? Okay, so suppose for example you are in night time you are sleeping, and always you will think of something, right? So thereby you will get a number of dreams, okay. But while waking up in the morning, you may not able to remember what dreams you may you got. Okay, so this is nothing but the same concept that we can able to apply, that we will have a number of data or paragraphs or a lengthy data or document or database is going to be there. From that we are interested into the particular sentence. Okay, so from suppose a particular book is there and a proverb is there that you would like to search whether in this book the particular author has written this proverb or not. So as to perform this sort of the check, you can able to make use of the engram data structure. Okay, so there are many things, like it can be a 1,000 page or as much a size of the document can be. From that you may be interested in a single paragraph or in a single proverb or onto the one sentence, whether it is available inside engram data structure. So while identifying whether, so it is going to be get based on to the probability, so either it is available over there or so how do we perform this check? Okay, um, so this is a equation has been given. We are looking for something, whereas we will have multiple entries, so probability with this w indicates the weight. Okay, now with this you may able to clear what exactly is the unigram or bigram or a trigram model. Okay, so here we can see. So n equals to 1 means what? Unigram. Okay, unigram means breaking your sentence into an individual word, that is called as unigram concept. So you are making here n as 1. So this is a sentence, suppose it is a written. So you are breaking it as this is a sentence. So individual element you are going to break. And if n equals to 2, n equals to means n is called as your size um, of your gram. Okay, so if n equals to 2, then it is called as a bigram model. Okay, so as long as the size of your sentence, you can able to construct either unigram, bigram, trigram, quadram or pentagram or any other size of what is the maximum limit of your sentence. Based on to that you can able to divide your sentence into the equal or fixed size. Okay, so here we need to remember the concept that onto the fixed size concept we are going to divide your sentence or your data. So in a trigram you can see n equals to 3. So this becomes 1. Okay, and is a sentence become the uh, second breaking. So likewise we need to apply here breaking logic, right? So this is a sentence. Um, it has been divided into 3 words when we do talk about the trigram or is a sentence. So dividing it into 3 grams likewise. In bigram we are breaking this sentence into combination of 2 words. In unigram we can able to break it into the combination of individual words. So this is called as engram. Engram means n is not fixed, n can increase. Okay, n can be 1, n can be 2, 3, 4, 5, likewise depends on to the size of sentence. Okay, so it may be increasing, but this should be whatever you have taken, that should be of fixed. Either n equals to 1 means in that sentence it should able to apply unigram model only, or otherwise bigram model or trigram or pentagram model. So this is also one of the example where we have broken by applying the concept of engram such as unigram, bigram and trigram. So what exactly is engram? Okay, how do you define the term called as engram? So engrams are neighboring sequence of items. What is called as engram? Engram is called as a neighboring sequence of items. Neighboring means besides the words. Okay. So after the sun is going to come, right? The sun is shining. So these are what neighboring sequence, besides sequence. Okay. This can be applicable for either individually to the words or to the letters or symbols in the particular document. So how do we define engrams? So engrams are nothing but the sequences. Okay, these are called as the sequences of words or letters or symbols in a document. Okay, so this is called as engram. So engrams are nothing but neighboring sequence of items such as words, letters or symbol in a document. So if this is a short sentence, if I'm using the sun is shining, so this is called as a unigram model. Okay, individually we are considering individual word. This is called as a bigram model, and the third one is called as a trigram model. So we can able to construct for n equals to of any length which is of fixed size. So what is the applicability of this engram data structure? Okay, why should we use this engram data structure? So earlier, at the this concept has been used at the time of very so many years before, at the time of World War II. Okay, so that time this concept has been used for the by the cryptographers for encrypt and decrypt the text. Means the coding language has been used which is not able to understand to the another team or who are participating in the war. So for that your confidentiality of the data is going to be get maintained. Coding language was used and which cipher and decipher the text. So for engram concept of data structure, so whenever you are using any sort of networking, so any information if you would like to transfer, that time it has been used at the time of World War II. So general uses of other uses of engrams are nothing but in terms of the spelling corrections. Okay, or we do call any sort of the word which you have not typed correctly. Okay, so that sort of correction also engram algorithm is going to handle. So engram is nothing but a data structure. Suppose what sort of the error or spelling corrections this engram is going to perform is, if we can look at this example. So this is the word computer. Okay, so two times you have used. So nowadays you will use a cell phone. So and onto your fingertips you will try to search. Sometimes the keypad will type double or triple characters, or sometimes one of the character is not going to be get typed correctly. So at that time you have to remove this or computer by making use of this engram data structure automatically removes the extra alphabet. Okay, so single character insertion, this error which has been occur here over here, extra character, that is going to be get resolved. Okay, or single character deletion, if extra character is there that you would like to delete off. So in any case, if you have written if you have used or typed multiple characters, or if you have not typed any of the characters, so that can be get resolved by making use of this engram data structure. Or if a particular spelling mistake also if you do, so see, for the sake of the single character, if any of the character in the particular spelling is wrongly typed or misspelled, so that can be also get corrected. Or adjacent characters, if suppose if you are writing wrongly, before you have to use T and then you have to use P, but you have written PT, so that changes also depends on to the word vocabulary the system is maintaining. Based on to that, so here engram data structure is used for your whatever the text you do type. Okay, the query which you fired at that time, certain mistakes, human errors are going to be get generated. So as to resolve those errors, engram algorithm is applicable. Okay, so spelling error detection as well as correction, this algorithm can be get used for engram data structure can be get applicable. So engram data structure, all of you clear what is exactly the engram data structure? So engram data structure is going to work based on to dividing the entire your data into equal parts. These equal parts are nothing but called as your what do we call it as grams. Okay, these are called as grams. Fine. um, so it is a data structure which is commonly used for information retrieval purpose, uh, which is based on the concept of breaking the your sentence into equal words or equal size. So we have seen how does it breaks the data or how does it breaks the sentence. Okay, so it can able to break onto the concept of n is nothing but 1 2 3, it varies. Okay, so based on to that it has got the terms such as unigram, bigram, trigram, quadragram, pentagram and so on. So where does what are the other applicability? As one of the applicability that we have discussed is nothing but the spelling error correction and detection, as well as at the cryptography end to retain your confidentiality of the data, it can be get useful. As well as the another third application this engram is offering you is of a text compression. What is the meaning or advantage of text compression? Compress means to reduce it to certain strength. Okay, suppose in your paragraph 90 alphabets are there, 90 characters are there, you can able to reduce it to 40 or 50. So by applying certain coded language it can be get removed. So engram is going to be get applicable for data or text compression. What do we call? Data or text compression by converting into your natural data to the coded form. So for the compression, trigram model can be get applicable for performing the data compression, as well as in various profiles such as SDI, selective dissemination of information, it is going to be get applicable. So that's why we write here engram in terms of max segment. Okay, how does it is going to find or search the token into the terms of finite limit. Okay, finite limit means either it can be a gram of one word or one alphabet, or it can be bigram, or it can be trigram or so on. So maximum segment is of engram is nothing but lambda to the power n. Okay, so why n is given here? So n is a fixed size which can be where we are going to break our entire sentence as a individually a single word or double words or three words or a combination of four adjacent words or a combination of five adjacent words depending on to your size of your. So it is being given as the max segment n is nothing but lambda to the power n. Lambda means this you can consider as a sentence. Okay, and n stands for unigram, bigram, trigram. Okay, what is the size you are considering while breaking or while dividing? That is called as n. Okay, so either it is a unigram model or a bigram model or a trigram or a what a quadragram model, pentagram or a hexagon, so or octa, that depends. So n is called as the breaking of words into equal portions, that is nothing but the n. And the lambda here is denoting what? It is denoting the sentence, or if it is for only for an individual single term, means a single word if you have used, then it does breaks into the characters. Okay, so what is the advantage it is giving? It is applying the finite limit on the number of searchable tokens. Okay, so this is about the engram data structure. So have you cleared what is engram data structure? Who is there over here? Yes, Mahi, 51.
Yes, ma'am. Clear. Understood, ma'am.
Okay, fine. Any doubts onto this engram data structure to anyone? Okay, fine. Then we'll move to the another topic. So engram data structure. So like your stack, queues, linked lists, this type of data structure or arrays you have seen already. So for information retrieval systems also we will use different data structures. So engram is nothing but one of the data structure which is applicable in the IRS for information retrieval. So the major job of engram is by breaking the words into equal portions. It can be able to perform the spelling corrections or sentence correction. Sometimes if you speech also correction, it can able to perform not only onto the what we do called text correction, but if you are giving an audio input and depends on to the besides vocabulary what has been passed, so it can able to correct your speech also. Okay. So many times nowadays you are using a cell phone and you are giving the voice input whatever the query you are having or the search you are interested to perform. So if you speak something and at the first end it may be taking depends on to the tone which you have used or accent different meaning, but in the fraction of second the correctness will come up. So this is going to be get applicable because of several algorithms are going to be get used. So for speech correction also engram algorithm is applicable. So for text as well as speech also it is applicable. Okay. So then next concept is pat. Okay. So what is this pat? Um, so pat is also one of the data structure. It is called as pat tree. Okay. So earlier we have seen stemming. Stemming is based on to the semantic and it is going to focused on removing the extra characters and making shorten of your words only to the root terms. We are obtaining the root terms. In engram we have seen it divides the entire sentence into equal portions. Okay, that logic is going to be get applicable. Now how does this pat so pat, what does this pat stands for, or how what is its extension? Okay, so generally speaking pat is nothing but this is a tree. Okay, that is called as a patricia tree. Okay, what is the name given? Patricia. Okay, PAT stands for the Patricia. So the earlier concept that we have seen engram. So engram is mostly applicable for your textual data and for the speech. So PAT works for images also. Okay, PAT is called as a Patricia tree. So this algorithm or this data structure is going to be get applicable for trees, for your text as well as images also. Textual data also it able to handle and image data also it able to handle. So we will see what is this pat. So pat means how it is uh, pronounced. So pat stands for practical algorithm to retrieve information coded in alphanumerics. Okay, so practical algorithm to retrieve information coded in alphanumerics, that is called as Patricia or its extension. Okay, practical algorithm to retrieve information coded in alphanumeric. So this is what's its extension. What does the Patricia stands for? So practical algorithm to retrieve the information coded in alphanumerics, that is called as Patricia. Okay, or Patri. In short, we will call it as Pat, but that is called as Patricia. And Patricia is again extended as a practical algorithm to retrieve information coded in alphanumerics. Okay, so how does this works? So whatever the input string that you are giving, the text that you are entering or any image which you are entering, so it does understand it or consider it by breaking into the concept of substring. Okay, it is going to obtain its substring. Okay, so if the input is a text, okay, look here. So in pad trees or in pad array, the input string is transformed into a searchable data structure consist of substring. Okay, so your string is going to be get further divided as a substring. Okay, so this concept you remember here, it is going to break your input into the substring. Okay, so the input data or input is called as the input stream is going to be get transformed into the concept of called as a substring. Okay, so pad tree is applicable for text and image and it is called as patricia, and it stands for practical algorithm to retrieve information coded in alphanumerics. So consider any example or any text. Suppose this is one example. Today is Thursday, and then followed by that the sentence is continuing. Suppose. So the what we discuss, it is going to consider it substring. Substrings are also called as a sysstring. What is the alternatively we can call for the substring name? The main string is going to be get divided as a substring, or we do call it as a sysstring. So sysstring 1, 2, 3, 4, as long as it continue, how much is the size of your query you have kept. Okay, so it starts with eliminating or removing the first character, then second character, then third character, likewise until the it becomes null. Okay, until your query alphabets are going to be empty or null, it is going to start and it will go on continue in this fashion. So if your word is today is Thursday, if your sentence is today is Thursday, so first string will be today is Thursday. In the second string, the first alphabet is going to be get removed. Likewise, in the third string, you will remove this O. In this fourth string, you will remove the D. In the fifth string, you will remove the A. In sixth one, you will remove the Y. So likewise, for the seventh, you will get this is. Okay. So likewise, it will continue. Okay. So removing the one characters. Okay, and then perform a check. So it is going to be get constructed with the possible combinations of systrings. So for any alphabet, any word which you have typed, so for that word, it is going to break it into an individual first letter, second letter, third letter, like that. It starts with elimination of those letters and it will keep on continuing until it becomes to the null. So several algorithms are there in which this patrese is applicable, such as for the prefix or range searching or proximity searching or for the regular expressions also. Okay, so these are the various algorithms on which this patricia tree is applicable, or repetition searching, or most frequent or most significant pattern searching. So for all this application, your pat tree is going to be applicable. So the major application, as we discussed, for the text searching or for the image searching, it is useful. So here we do talk in terms of the pattern. Okay, so any text that you are interested to search from a document, that particular element is called as a pattern. So you can able to find out some pattern, so you require to match it with certain pattern. So you give some text. Okay, so if I consider, if I do talk in terms of array, so you have typed some 10 letter and that becomes one word. So that text is going to be get treated from 0 to n minus 1. Okay, and to the last element. So it, as it is starting from 0, so we do talk in terms of n minus 1. So 0 to n minus 1 your text. Okay, and a pattern 0 to m minus 1. Now uh, suppose now what is here called as text and what is called as a pattern. Okay, so suppose if you are having one entire one page is there, okay, or one book is there, that you do call it as a text, and the string which you are interested to search, that is called as a pattern. Okay, in this particular book whether this proverb is available or not. Okay, or this particular sentence or this image is available in this book or not, or onto this document, suppose document size is of 200 words or something else. So text is called as the entire. Okay, and pattern is called as the thing which you are interested to search. A particular image is associated with this document or not. So that is called as a pattern. So entire document is called as a text, and pattern means the either the text or image which you are interested to search, that is called as pattern. So that's why the search function, okay, we have to make use of the search function, and this search functions begins as um, character pattern, means the pattern which you are interested, comma character text from the given text you are interested. So here we are writing text as n. Text means entire document, and the pattern is called as m. Okay, n and m. So n is called as your text and m is called as pattern. So definitely from whom you are searching should be lengthy, or which is of more size. That's why we will write assuming that n is greater than m. What do we write over here? N is greater than m. M means the pattern or the particular text which you are interested to search from the huge size of document. That document may be either a paragraph, or it can be some pages, or it can be more than that. Okay, so that's why we do write n is greater than m. So pattern should be smaller than the entire text, or we do say n is greater than m, means the text is greater than the pattern. So various algorithms are used for finding out the pattern, such as KMP, Robin, finite automata, Moes algorithm. So these are nothing but the name of the algorithm to find out the patterns. Okay, so these algorithms you need not have to study. You just need to know what is the pat tree. Okay, how to construct the pat tree, what is the applicability area to find out the pattern, to trace out the particular text is available inside the whatever the database is maintained at the backend. So here the time complexity which has been given is represented as O of n. Okay. So O of n, how much is the time the system takes to find out the particular pattern or to pre-process the pattern. So that is called as O of n. What is exactly n? N is the length. Okay, here n is called as the length of the text. Suppose a document in which this proverb is available is of only 500 words, so definitely you will get it at the faster space. But if it is of suppose 50 pages, or if it is of 100 pages, or if it is of 1000 pages, then the time that is going to require to calculate the where exactly your pattern is going to vary. That's why it is written as O of n. N is nothing but here representing the size of your document, or the size of your paragraph in which you are performing this check. So that is O of and the time complexity. So then we can able to find out this pattern. Okay. So like from any book, you are interested to identify whether this particular sentence is available or not in this book. So likewise, this is nothing but called as one of the example for text searching. Now, while using this patricia concept, you require to build a suffix tree, okay, or a suffix tree of a text, or it is also called as a trie, okay, TRIE. It is also called as a trie. So let us have a example, okay. So here we are taking a string known as banana, okay. First, while obtaining the trie, we require to know all its suffixes, okay. So what is the information is available, with that we need to trace out. So whatever, whichever the word which you have given, so as I discussed, we require to obtain the, in the first slide, strings. So how do we obtain the string? By eliminating end. So look at for this example. So we are going to, for all suffixes we are going to do. So here we have seen, this is the first one. We have eliminated here B, then here we have eliminated BA, here we have eliminated BAN, then BANA, and here N is eliminated, here A is eliminated. Like that it reached to the empty one, okay. So we are going to eliminate one by one all the uh, characters, and then the middle one we can able to trace out. The pattern can be easy to found. So likewise, from this whatever the suffixes we have obtained, we require to build the suffix tree, right? So the steps are generate all the suffixes of the given text. So we have generated here all the suffixes, and the second step is to build a trie, okay. From all these suffixes build a trie. Trie can be, firstly you can obtain a simple trie, then you can make it as a compress. Compress means somewhat reduction you can able to do, so as to reduce the size and reduce the processing time. So firstly, you have obtained all these suffixes, okay. After obtaining all these suffixes, you are going to construct a trie. So the first one is this one. It started through this path from left hand side. It is going to have, so this one completely it has taken B, A and A and A. Next one it has eliminated B and A and A and A. This side empty one will come. Okay. Left hand side all the suffixes will come, and here null will come for the first one. Secondly also here this one is going to come. Likewise NA, okay, empty for NAN, okay. All this we have considered. So this is nothing but a trie. What it is called as a trie. From this we can able to construct a compressed trie also by eliminating some of the branches, okay. um, so note, here we have obtained a compressed trie for the string banana, okay. And then we can able to search a given pattern. So searching means what here now? Again, we require, as we are constructing a tree. So while constructing the tree, it starts with a root node, okay. Then it will have several branches and follow to the, until the end it is going to reach. Now from this, suppose banana, if you are interested to find, suppose NANA or NAN or na, okay. So this sub pattern can be get easily found. So how do you try to find this? We can able to find it by firstly starting with a root node. So see here some steps has been given to find out the element. So starting from the first character of the pattern and root, we have to perform the following steps. So this pat algorithm, as we discussed, it is going to applicable for finding the pattern, whether the particular text is available or not, or a particular image is available or not. So while doing so, here we have identified like for the current character of pattern, if there is an age from the current node, then follow. Means while you, when you are starting from the root node is nothing but the main node, and then there it will have certain ages. Means the tree is going to be get grown, or it is going to be get constructed. If there is a age, we need to perform the search, and we require to go as long as we are able to find out the particular text. If the particular text is available there, then we can say pattern is found. If the particular text is not available, then we can say pattern does not exist. So the same algorithm is given over there. If there is no age, print the pattern does not exist. And if there is an age, okay, from the root, you have to follow that age until you are going to get that particular term. So here we can able to find out this, okay. So if you are able to find out for now NA, so you will get this pattern, and this text is going to be available. NA is available inside this suffix tree. So the major application of this is for pattern searching, to find out the longest repeated substring, or others such as palindrome, okay, that string operation palindrome, or common substring finding. So these are the several what we call applicability this is going to provide you. So this is called as the pat. Pat means patricia tree, okay. So pat and which engram we have covered today, and today I will take your one more class 3 o'clock, okay. So all of you log in today 3 o'clock, so that we can fast up the syllabus. For only Monday and today and tomorrow I am taking the extra class, okay. So whatever is the pending syllabus, that we can finish it off. So pat tree, everyone understood what is this pat? So it is applicable for searching the pattern, okay. So depends on to the substring concept. We do try to divide the entire string into the substring and try to find the particular pattern after constructing a, obtaining the suffixes, and then building the uh, try. Once the try is available over there, we can try to find out the pattern. So this various algorithm can be get applicable for pattern finding, and those can be nothing but the KMP or Robin Carp or finite automata, okay. So applicability is for searching, prefix, range, proximity, regular expression, okay. So this is nothing but your pat algorithm or pat data structure. How does it works? So if you have been asked algorithm, you can write these steps. These steps are here, right? Okay, so need to write the entire concept, then this is the tree and all.